about, or now we're going to talk about photon vision. And basically, photon vision is our vision system to look at APL tags and figure out where the robot's position is on the field with that. So here, let's look at an example of how it works. So here I have an APL tag, right? And I'm showing it to the right camera, you can see over here. And oh, I've got my hand on there, but it's using the APL tag pipeline, and it's estimating the 3D position of the tag on the field. So relative to our robot, this is what the tag looks like. And so if I move it around, you can see it like moving around in 3D as well. And so if we look at what our robot code sees, you can see that this green estimate is where the robot thinks it is. And so it's estimating, that the robot is over here by the right camera. So this tag that I'm holding up is this one by the stage. And then this is what the vision estimate is telling it. And so we can also flip through, go through our other cameras. That's our left camera. It'll probably take a second to change, but here we can also show this thing here, and you can see the estimate there. And can you hold this up? Make sure your thumb isn't on the tag. And if we go to here, you can see it's flipped around the other way. That's the left side now pointing towards the tag. And so the same is true of our back camera. Can you show it to the back camera now? Once he shows it to the back camera is a little lower down. Hey. There the like vision sees it, and so the back of the camera is pointed towards there. And so vision is really powerful to estimate where you are on the field like that. So before we move on, let's look at a bunch of things that you can change about vision to try to make it better. So usually for our cameras right now, we have auto exposure on, but when we have our I guess our global shutter cameras, you'll want to configure this. And so exposure just tells the camera how much light to let in. So if the exposure is really low, it's not going to let that much light in. And the more we raise it, the more light it lets in, and the picture becomes like completely white. So I'm going to leave it. I'll leave it as auto exposure for now. And then another thing we can change is the brightness. So it just like makes white whiter and like black or darker shades like darker. And so you also have to like play with this and tune it to whatever you're looking for. You can also change the orientation of the camera. We don't need to do that here. And you can also change the resolution. So for different resolution sizes, you need to calibrate them differently. And so the way you do calibration is you go to cameras, and then you select your camera. And basically what we want to use is this website called calidb.net, and then upload the calibration from there into Photon Vision. But another way you can do it is by hitting start calibration and then showing it a checkerboard and taking pictures at different resolutions. So here you can see this camera is calibrated for these 3 different resolutions. And so if we wanted to, we could switch between them here. Another important setting here is the stream resolution. So we don't want to use too much bandwidth on our robot. So that's why it's set to a low resolution here. So it's not gonna send the full 800 by 600, I guess, stream resolution. It's gonna be lower. And we can set it even lower if we want. That would just give us like a lower quality result here. Okay, can you hold up the APL tag again? Yep. So this next category, this next tab, APL tag, tells it what kind of APL tags to look for. So these are more complex APL tags, and then these are like simpler ones. And then basically, some more things. If you look on this side, then you'll see all the targets that the camera is looking at. And just some more things you can do to improve how well your vision looks at the tag is by increasing decimation, which basically it's kind of like blurring for the APL tag algorithm. And so it may make your algorithm better in some cases. So here you can see I'm blurring it a bunch, and it's like relatively the same. Threads is just the number of CPU threads that the APL tag detector uses to run it. So theoretically, more threads is better. But our Orange Pi has a maximum of 4 threads, I think. And then these are just some more things. I don't really know about those. And then multi-tag pose estimation and all that cool stuff. So if I go to my left camera, we also have another mode, note detection mode. So if we had we don't have any note beam pieces here on us. But if we had a note, then we could show it to the camera. Like it would look like this or something. Like imagine this is a note, right? You'd see it as a target here. So in the code, you can go through and basically use the information of where the note is relative to the camera to, like for example, drive to it or calculate the estimated position of the note on the field. And so for note detection, the only different settings are, since it's a machine learning model that's running note detection, you can change the confidence level. Wait, Grace, can you get a note actually real quick just so we can show this?
All right.
Is the confidence level of the note it sees. So a higher confidence means the algorithm thinks it's more likely to be a note. A lower confidence means it's less likely to be a note. And it might detect like random things as being notes. So if I make the confidence like 0.05, you can see it thinks that is a note for some reason. That's why we tune our confidence to make sure we only have things that look like notes. We can also tune the area. So if an object is too big and it thinks like, if it thinks the entire frame is a node, then we can tune that out by going like this. We can also set the like ratio of how big our target should be. And we can also tell it how to sort by our target. So here's just by the largest target. The largest target will occupy the greatest area on screen and probably be the target closest to the robot. That's all that there is in Photon Vision. You can also use your cameras. For example, this is the right camera. Hi. You can use it as a driver camera, and so it converts it to color. The APOTAG detection algorithm uses camera feed in black and white, which is why it's like that there. But if you just wanted to drive around using this, you can put in driver mode, and then it's pretty low latency. I don't know why it's 0 milliseconds. That doesn't make sense, but yeah, there's APOTAG detection. And so we have 3 cameras running off of 1 Orange Pi, and we still have like 30 FPS, which is really good. Oh, you got to know? Okay, sweet. So let's just go back to our left camera, just to show you how it works. So here you can see he has a note, and it's detecting it with pretty high confidence, 90% confidence. And so, for example, if this note were on the ground, we could have code to drive up to it and get it. And so that's really cool. And then the last thing you need to know about Photon Vision is when you're setting it up, you need to make sure to configure your team number here and have a static IP. Otherwise, it won't work on the field. So if you have multiple coprocessors, you need to have different static IPs. But for this one, it's just 10.12.57.11. And then you can also configure the host name here. That's about all you need to know about Photon Vision. Thanks for listening.